of DHCP as a network's backstage manager, the one quietly handing every device its script, costume, and exit plan before the show starts. When your laptop joins a LAN, it has no idea who it is or where to go. DHCP steps in and auto assigns the essentials: an IP address, your seat number, a subnet mask, the row boundaries so you know who counts as neighbors, a default gateway, the aisle to the other rooms, an example, the other networks, and DNS servers. The directory, so Netflix.com, isn't just gibberish. Crucially, it lends these settings on a lease, more library books than property deeds. So addresses can be recycled cleanly as devices come and go. Formally, this is the dynamic host configuration protocol, standardized for IPv4 in RFC 2131 and for IPv6 in RFC 8415. The IPv6 world adds some grown-up nuance. DHCP v6 can run stateful, where the server tracks who got which address and can even delegate whole prefixes to downstream routers, handing out blocks of seats, not just one. Or stateless, where hosts build their own address via SLAAC, which is guided by router advertisement. And DHCP v6 supplies just the extras like DNS. It's like a hotel that either assigns your exact room, which is stateful, or lets you pick any room on the floor and simply hands you the Wi-Fi password and pool schedule. That's stateless. At a system level, DHCP can cleanly separate addressing policies, which is a central authority consistent options, from endpoint configuration, where every device figuring itself out. It reduces fat-fingered static configs, speeds up onboarding, and keeps the network seating chart coherent, so your packets don't play musical chairs every time you plug it. If IP networking is a city, DHCP is the transit pass kiosk you see everywhere, from the corner store to the Union Station. In your living room, the consumer router that came with your internet plan quietly runs a DHCP server by default, handing out addresses plus directions to laptops, phones, smart TVs, and that rebellious Internet of Things light bulb. It sets a private address. Think of 192.168.x.x. The subnet lines you shouldn't cross, a gateway to reach the outside world, and DNS, so cbc.ca isn't just numbers. It's the plug in and play you take for granted while you binge watch The Last of Us. Scale that up, and the same dance powers branch offices and campuses. Here, DHCP gets a gym membership, multiple VLANs, voice subnets for IP phones, and central scopes with reservations for printers and servers. Because broadcasts don't cross routers, DHCP relays or IP helpers on the layer 3 interface act like an usher, forwarding requests from each floor to a central DHCP brain in the data center. Admins sprinkle in options such as use the TFTP for phones, these DNS servers for labs, shorter leases for guest Wi-Fi, and lock it down with snooping and trusted ports so rogue boxes don't impersonate the kiosk. Out of the internet edge, ISPs use DHCP as part of the DOCSIS boot ritual. Your cable modem wakes up like an Xbox loading a game. First, a DHCP request to grab a temporary IP and pointers to the TFTP config and time of day server. Then it downloads its playbook, syncs time, and registers with the CMTS. Only after that does your home gateway run its own little DHCP for your devices. Same protocol, different arenas. From couch to campus to carrier grade DHCP, which is quiet logistics crew that keeps packets from getting lost on tour. If IP networking is a city, DHCP is the transit pass kiosk you see everywhere, from the corner store to the Union Station. In your living room, the consumer router that came with your internet plan quietly runs a DHCP server by default, handing out addresses plus directions to laptops, phones, smart TVs, and that rebellious Internet of Things light bulb. It sets a private address. Think of 192.168.x.x. The subnet lines you shouldn't cross, a gateway to reach the outside world, and DNS, so cbc.ca isn't just numbers. It's the plug in and play you take for granted while you binge watch The Last of Us. Scale that up, and the same dance powers branch offices and campuses. Here, DHCP gets a gym membership, multiple VLANs, voice subnets for IP phones, and central scopes with reservations for printers and servers. Because broadcasts don't cross routers, DHCP relays or IP helpers on the layer 3 interface act like an usher, forwarding requests from each floor to a central DHCP brain in the data center. Admins sprinkle in. Picture a big music festival. After the gates open, you walk in with no wristband, so you don't have an IP address. So you head to the wristband tent, which is a DHCP server. The exchange is quick and choreographed. This is classic DORA. Discover. You shout, anyone handing out wristbands? That's your client broadcast. Offer. The tent waves back. I've got one in your size, plus a site map. Request. You point. I'll take that specific one. Acknowledge. They strap it on you and hand you a map. IP, address, subnet mask, default gateway, and DNS is all included. Under the hood, IPv4 clients yell on UDP 68 and servers listen on UDP 67 because that shout is a broadcast and routers don't forward broadcasts. A DHCP relay or IP helper at the nearest router acts like a runner. It hears you on the field, then sprints your request across the tent on another field. And then it brings the answer back. Same choreography, no need for the server to live on every VLAN. There's also renewal rhythm. Think of it like checking that your wristband's still valid later in the day. Before the lease expires, the client quietly renews. If that fails, it tries a wider rebind. No drama, just housekeeping, so addresses don't collide like two tour buses fighting for the same parking spot. In IPv6 Pavilion, the dance has new moves. SARR, which is Solicit, Advertise, Request and Reply, all on UDP 547 and 546. Here, DHCP v6 can be stateful. The server assigns and tracks your exact request, or even a whole prefix for your downstream gear. Or stateless, you self-assign using SLAAC from the router advertisement, while DHCP v6 supplies just extras like DNS. It's like picking any open seat after the usher tells you which section you belong in. SLAAC. Then grabbing a venue grid and Wi-Fi details from the help desk, which is your DHCP v6 options. Networks mix and match. Set the RAMO flags to signal. Use DHCP v6 for addresses options. Use SLAAC for addresses, or use both depending on design goals. Bottom line is, DHCP is a festival logistics team. DORA or SARR gets you identified and oriented fast. Relays handle the cross-field courier work, and in IPv6, SLAAC plus DHCP v6 share the load so everyone finds a seat and the show goes on without IP collision or configuration chaos. Picture a DHCP is the difference between a campus network and a group project with a shared Google document versus 20 people emailing. Final v7 really final.xlsx with static IPs. Every device needs a hand-typed address map, mask, gateway, and DNS. One typo, and your printer goes feral. DHCP centralizes all of that. A single authoritative service hands out good tickets automatically with leases that expire. So the seating chart doesn't ossify. It's Uber for IPs. You request a ride, that's your config. The dispatcher matches you to a clean, conflict-free address. And when you're done, the car goes back into the pool. Ops can change policy in one place. Swap DNS, shorten guest Wi-Fi leases during midterms, reserve a stable IP for the card reader without touching 100 endpoints. That's why home routers ship with DHCP on by default, and why enterprises lean on it across VLANs via relays, fewer fat-fingered configs, faster onboarding, and coherent address management at scale. But classic DHCP has a superpower and a kryptonite. Superpower, it's blissfully simple. No per-device certificates or handshakes. Kryptonite, it doesn't authenticate who's acting as the server. So a rogue DHCP box can hand out free addresses that quietly set the attacker as your default gateway or DNS. Like a fake airport kiosk printing boarding passes that route you through their special security line. The fix is to move the bouncer to the edge of the network. DHCP snooping on access switches, mark uplinks, trusted edge ports, and untrusted. So bogus offers Ack get dropped. Option 82, insertion validation. So the server knows which switch port originated a request. IP source guard uses the snooping table to block forged source IPs. And where it fits, 802.1x NAC, so only authenticated devices ever reach the kiosk. Do that and keep DHCP's effortless, centrally managed Vibe Starfleet level coordination with far fewer red shirt moments. DHCP isn't one product so much as a role different gear can play. Like the same actor showing up in widely different shows across the streaming universe. 40net, aka 40gate. Think of a 40gate as the campus concierge that can either hand out keys itself or phone the back office. Any L3 interface can run a DHCP server, multiple scopes and reservations, or flip to relay and forward requests to several upstream targets. It's very choose your class server when you want local, fast onboarding, relay when a central IT team holds the address book, and so on. Palo Alto networks or the PAN firewalls are the disciplined grad student of the bunch policy first, but happy to do some RA if you ask nicely. On L3 interfaces, you can enable a straightforward DHCP server for that subnet or config relay to punt requests to a shared server. It's tidy and explicit. Define the scope, commit, then let security policies do their thing. OpenSense, that's the open source tinkerer's dream. Like Lego Tectonic for networks. Out of the box, you get DHCP v4 and v6 services. Modern builds lean on Kia with DNS mask, which is also common, plus a relay option if you centralize elsewhere. With ISC DHCP phasing out, OpenSense leans into newer engines while keeping the web UI it's user friendly for home labs and small campuses. Cisco iOS and iOS XE. This is where DHCP goes full enterprise. Routers and L3 switches can run a DHCP server. Think IP DHCP pool, or act as relay agents with IP helper addresses on each SVI, and they can stamp traffic with option 82. So the server knows exactly which switch or port a request came from. Pair that with DHCP snooping, and you've got MCU level crossover between addressing and edge security. Home routers and switches, they're your all-in-one box from your ISP. It ships with DHCP server enabled by default because it just works. Beats README a CLI for living rooms. Many UIs, such as TP-Link and others, even let you flip to relay if you graduate to a central server later. It's the plug-in and play vibe that keeps Netflix nights drama-free. On the internet edge, we got DOCSIS, which is cable modems boot like a game console loading DLCs. They use DHCP to grab a provisional IP and pointers, pull a config via TFTP, sync time with ToD, and register with the CMTs. Only after that ceremony does your home gateway start handing out local leases to your device. Across all these platforms, the plot is the same. Hand out good addresses fast, keep policies centralized when it helps, and scale gracefully with, relays. Just perform on different stages with their own props and costumes.